Welcome again to the ds-incubator. Today is the last session on the topic A Holistic Workflow. We are still covering the book What They Forgot to Teach You About R. And the very first section of the book talks about this idea of working in a way that is oriented towards projects. And from that series, the only two topics that I would like to really cover are the previous last two here. How to name files so that they order nicely on your default, kind of files browser. Also, so that they are readable for humans and also for machines. And then, secondly, how to organize the analysis itself, like the project. What it could be a good internal structure of a project, so you can find things easy. And some other person can also find things easy. And finally, there is this topic that I may leave out, some tools that are precisely designed to kind of to automate some of these workflows. But that's a fairly advanced topic, and for now, I want to focus on the minimum things that we need to all know to work effectively. So I need to do some to prioritize topics, so that might be out. So the next meetup will make a pause very likely. This is still to be confirmed, but we have a guest, and it's gonna be a topic that is not related to this idea of the book. And then we will resume the series with a few more topics that are a bit more technical. But when you walk away today, you will have in this series you will have heard about the most important things about R that are not typically taught and that can improve our workflows considerably. And then the second part of the series, after the one next time, is going to be about things that are important, but probably not the ones that are the most important ones, at least not when you start. So the rest of the meetup is going to be mostly interactive, but first I want to do a little glimpse about the things that we're going to be talking and then kind of demonstrate them. So the first thing I would like to talk about is how to name files, and these ideas come from Jenny Bryan. It's linked here, as you can see. She has a really good presentation about this topic. I'm gonna make this a little bigger. So the first thing I would like to do is here in a group kind of talk about why these files under the heading no might be bad names for files, and then while the files under the heading yes might be better options. So how about this one here? Like, for example, the second one, Joe's file names use spaces and punctuation .xlsx. Well, that's kind of trivial maybe, but anyway, everyone would like to break the ice and tell me what you think about that file name and why it might be not a good one. Just go ahead, don't need to raise your hand.
I heard spaces.
Concerns because he is the name Joe.
There you go. What?
I'm just making a joke. So
So I heard spaces take up more memory or something. Number one. Number two, depending on the language, there might be errors on how the file name is read. I don't know.
Right. I don't know about this the memory, but certainly the spaces are not interpreted the same way in different platforms, and some programs just don't like them. Like, for example, I remember a problem in RStudio where people couldn't see files, or the session would crash. It's like something like really bad because the path to the project, the RStudio project that they were working with, had spaces. Like, for example, a username in your computer that has a space is a really bad idea, or like a 2 degrees symbol in a name is a really bad idea, like our horrible Dropbox folder name, unfortunately. How about this one here, like the last one, contains look how it contains the string, delete this and your career is over. How easy it is to find that information in that file at first glance. Not very easy, right? And what's the risk? Why would that be? I mean, why the whole thing would be a bad name? What's one of the problems there?
The punctuation, specifically the parent and the @ symbol and the star, are all really problematic when trying to deal with file names programmatically.
That's a pain. How about the semantics of things there? So it looks like, there is information there that is trying to warn someone, using this file, this project, that this file contains very important information, and if you delete it, your career is over. I mean, you really want to not delete it, but you skim like a project that contains that file. Is it easy to kind of read and to see that information like right away? Is it obvious that that's a very important file, or is that not so easy to see? Go ahead, whoever rose their hand.
Yeah, I also see that there's some pretty weird characters in there, and since it's super contextual to our organization, I'd like to mention also putting the degree symbol and other things like this in a file name often ends bad, as we all probably know all too well by this point.
Exactly. So spaces, other symbols are horrible. And here, what I wanted to highlight with this file name is the readability. The file should be readable for machines, of course, and that was the problem, for example, with the file name that contains spaces, because some machines just cannot read it properly, and then you just fail to read the file. But then also humans, right? So if the file contains very important information, if you delete it, your career is over. You want to just write that in a way that is more readable, smashing all the words together. It's not very readable. Burying that information around a bunch of other characters, and in particular symbols, is again makes it even less readable. So readability for humans is crucial. Readability for computers is crucial. And what else? I think Jenny here wrote some principles. Yeah, machine readable, human readable, and plays well with the ordering of things. So notice how the yes section contains names that are different. In that, for example, the symbols they contain are pretty friendly for computers. Like these hyphens and these underscores are very fine, and computers can read that. Also, Jenny encourages people to separate the semantic components, or the semantic metadata components in the file name by underscores. So, for example, if you separate something with a hyphen, that all belongs to the same metadata component. So this is all a date, right? But then there is an underscore to separate the date from other kind of information. Like to the right of the underscore, she writes, abstract for SLA. So abstract for SLA, the whole thing is one piece of metadata. So that means that you could also write a program that knows that, okay, every time you see an underscore, separate the string, and then you can recover metadata from the file name. And then the sorting, like for example, figure 01 and figure 02, those files will sort automatically one on top of the other in a meaningful way by just any default file browser. So that's also cool. And then in terms of the date here, what's going on? Like why are we putting here, for example, not the day first or the month first in the date? So there is.
So when you sorted files in logical order.
Exactly right. So the Jenny has a really nice slide that says the comprehensive map of countries that in the world that use month of the first component of the date, and that's US, and I think it's American, and a piece of Canada, really. So I mean, if you think that the entire world uses dates as you use them, you're likely wrong. So there is a convention that this format for the day, where you first put the year, then the month, and then the day, as CJ says, not only sorts nicely, but also is like an international convention that that everyone can agree on. It has a number, ISO something. Maybe someone knows it here.
I don't know the number on the hand.
8601.
There you go.
There you go.
8861.
There you go. Yeah.
But I would add to this that it's also like the order in which they go. So not only it's switching day and month like Americans like to do, which is terrible, but also like in this format, I think what is common, at least in Germany, for instance, is day, month, year.
Mm-hmm.
That is also like unfortunate for sorting, because then you get like everything that was on the first month of the year sorted together, and then everything for the second day of the months of all months together. So if you put largest thing first and then increasingly less large things, then you get good sorting.
Exactly. Yeah. Okay, I'm gonna go back to the faces. Someone rose their hand. That is, who is that one? Can't see them. Go ahead.
Oh, I just posted a link to XKCD in the chat.
Oh, cool. Awesome. Let's click it here for a second so it's recorded. There you go. Okay, back to the slide. So this is the topic of names. I'm gonna demonstrate in a moment how that applies to a project. And then the other topic I wanted to first glance and then kind of show a live demo for is this idea of how to organize projects for a data analysis. So there is a really nice figure that the Tidyverse team has been kind of pushing forward for a while now, that shows the different steps here in white of the data science kind of workflow, where you first kind of import some kind of data, you tidy it, you transform it in some way, and then usually you visualize it with figures. Maybe you create a model, maybe you need to iterate that into that loop again and transform the data a little bit more, visualize it again, and you keep understanding your data until then you communicate your findings in some kind of report. So that is like a very generic workflow. And now you can design your project structure. You can organize your project in a way that maps to that very generic workflow in the data science world. So when it comes to code, and this figure is about code, usually when you import data, sometimes you just need to have a feel for what the data contains. So Jenny has this file called smell test, like a small file where you just explore, and the output of that is just the wisdom that you gain from exploring the data. Then at the stage of tidying the data, you need some code to tidy that data so that the tidying process is also reproducible. So she has a file called wrangle.r where she does all that stuff from going from the raw data to the data that is actually then going to feed the rest of the analysis. Then if you need some code to visualize the data, then you can have a file that does just that. And if you need to create a model to, for example, understand the relationship between two or more variables, then you can have another file called model.r. And then when you're done with that, you need to kind of glue all these pieces together so you can write a report. And a good platform to do that is an R Markdown file. So she has this file called report R Markdown. So I'm going to continue to the next slide to show how that relates to data sets. So before what we saw is code, and now what we're seeing is kind of inputs and outputs. So the very first input is always the raw data. Sometimes it comes from Excel spreadsheets, so it might be an Excel file. Then after we wrangle the data, after the stage of tidying the data, the output of that would be a clean data set. Something like data.csv could be a good place to store that data set. Then the output of the figures that you create, if you're going to store them somewhere, you may save it in a folder called fix, like figures or something, where you have figures. Inside figures you have a histogram in PNG format, and you have like a dot file, a points, a scatter plot. Scatter plot. Thank you. PNG file. So that could be a meaningful place to put those figures, right? And then the models, you can save the entire R object that contains the model, the fit to the data. You can save it as an R object in RDS format. And this ESTS, maybe someone here, some analyst is more familiar with that. I don't know what that might mean. You can also save that apparently in CSV. So we saw the code, we saw the inputs and outputs, and Jenny put together this little table that gives at a glance an idea of all of that. So input, the very first input is raw data. You have a little R code, you may call it smell test, and the output of that is just with some. The raw data in some other file, you import it again and you actually wrangle it, and the output of it is clean data set, like data.csv, and then so on and so forth. So here this table summarizes the two figures that I showed you before. So now what I would like to do is go to RStudio and try following Jenny Bryan's suggestions, and then add a little bit more structure through folders, so subdirectories of the main project directory. Also because I realized that I haven't covered like showing how you actually create an RStudio project, I think. So I'm gonna do it. Now. But before jumping to the demo, do we have any comment here in the group? Questions? Okay, this is now about the time when someone reminds me that we are close to the end. So the rest of the meetup is going to be a demo and pretty much interactive. So let's open the floor for you to stop me and ask questions at any time. Unless there is more than one hand, you can just speak up. Okay, so as you can see, and this is like a review of the whole series so far, the top right of my RStudio IDE shows project none, so that's not a good indication. We want to work in projects. We want to work in a to display a project-oriented workflow. So the first thing we do is we create a project. If you do like pointing and clicking, you can come here and you can create a new project from here. Or if you like to type things, as I do, you can use this package to create a project, and then you create it wherever you want. But generally it's a good idea to have a dedicated folder for all your projects. In my case, I use it inside the. I use a folder called Git because all my R projects are always tracked by Git. We haven't talked about Git yet. You don't need to know it out of this series, but maybe we're gonna cover it later on the series. And there is an entire series about that already in the ds-incubator. So I'm gonna give the name. So inside the Git folder that exists already in my computer, I'm going to give a name to this project. Let's say ABCD. So that's gonna be my project. So RStudio now is gonna open the project I have just created. And you will see already that there's a tiny bit of structure. So the default projects already come with a folder called R, suggesting that it's a good idea to put there anything that is R code. So the other thing, or at least two things that I like doing in every project is having a Readme file, and again, you can use this package to create a Readme file. You can use Readme RMD. So that calling that function will create and open a new file, as you call it, Readme. So that file will have some data already in it, some information in it, where it prompts you to type, what's the goal of the project, and then a bunch of other things. So I would just remove that and explain the goal of ABDC is to show how to structure a project nicely. So just a high level of what the project does, and here you could insert code. So that README and the project structure is the minimum things that I would think every project should have. But now I'm going to, and then you could follow the recommendations of Jenny to create the files that and folders that she recommends. But using the prompt that we got here from creating the project from scratch, where there is an R folder there, I'm going to kind of show the subfolder structure that I recommend to organize your project even better. So let me close this ABCD project and instead open another one. Remember that using an IDE is a good idea when it comes to managing projects, because it allows you, to close a project, open another one, do a bunch of things. Like for example, now I'm gonna click on ABC, which is another project that has a little bit more structure. So it's a bit advanced in the ideas that I want to transmit to you. So I'm gonna use the RStudio IDE to go to a recent project, the one that you're looking at here, where basically I have a bunch of problems in this project that I would like to fix with you together. So this project follows the recommendations here from Jenny, except that has a few problems that we're gonna fix together as a way to review what we're covering here today. So for example, we have a smell test file, and one thing that this file name has that is not very good is that the underscore is separating two pieces that belong together. So smell test is is a phrase, but the two components, the two words smell and test, refer to the same thing. So I think that a better name for this could be smell-test. I'm being very picky here, right? But it's just an opinion, and this is an opinionated way of creating your projects. So opinions are fine. You may have your own and develop it further. Another thing that I like is for my files to always use lower cases, so that I don't need to remember if something is lowercase or uppercase. I just know that I always use lowercase, so there's no confusion there. I also have the Wrangle file, but then there is no ordering here. So if the smell test comes first, I think it's a good idea to first call it 01 and underscore to separate this part of the metadata to this other part of the metadata. And then Wrangle could be called 02 because it's something that I do after I smell test the data. So something like that would be a little better. And now, already I can see how the ordering of things are good. So the file 03 make fix is good. So let me sort the other way. So I have first. Yes.
Just a real quick note to everyone. As a group, we need to come to a collective decision on case in file names. I would strongly encourage everyone to only ever use lowercase file names. The reason for that is some operating systems use case-sensitive file names, some operatings do not, and some operating systems are inconsistent even with themselves. So, for example, if I tried to open up 01 smelltest.r but with a capital S and a capital T, it would open the file that's listed there on my Mac, unless I had a different file with that same file name with capital S and capital T, and then it would open the other file instead. So just always using only ever lowercase characters is a simple way to not have to deal with that problem.
Thanks a lot. I love that. I love that. So these three files are R files. So it's a good idea to create a folder called R and stick them all in there. So once I have the folder right there, I can just, in RStudio, I can just click these three file names, and then in more, I can move them to R. So slowly, this project is taking a little better shape. When I do that, I also notice that there is a really ugly file name here. It has a space, so let's rename it. Raw data, let's call it raw-data. Also, in our packages in particular, you will see that the raw data goes inside a folder called data raw. That's kind of a convention. It's not compulsory, but it's a nice, to follow conventions. It makes life easy because you don't have to think too much. So I would just move that file to there, like data raw. What else do we have? We don't have data yet because we haven't wrangled the data yet using these scripts. Maybe another place that I would like to, another folder I would have, and then I would probably stop there, is reports. So reports, vignettes, articles, to me, they are all kind of different names for the same thing. So basically a place where you glue the different parts of your analysis and you derive some wisdom from it. And the reason why it might be a good idea to have a folder is because you may not have just one report for a single project. So in one project, with one data set, you can create very many different reports. So this is taking shape. So now maybe in my Readme file, I'm going to run this file and also show a little bit the structure of Readme, but also in general, this file is also structured as any other report good. So where you have, like a meaningful title in R Markdown, you can create a first level title with, like a hash, and a second level title with 2 hashes, and a third level with 3. You get the idea. And then, the high level goal of the project. And then it's very common that you would see first the packages that the project uses, or that this particular report uses. So in this case, just for demonstration, I'm using the FS package, and then any code. Generally, first you start with loading functions if you need them, and then with actual analysis code. So FS has a function called dir_tree that shows the tree of the directory. So this report, all it does now is to show you what we have accomplished. So now a project that was a bit of a mess to look at now is organized in a really nice way. So in the R folder, we have files number 1, 2, 3 that suggest which is the order in which you should you do those steps. A smell test first, a wrangle stage where you transform the raw data to actual analysis data, and then maybe a third script where you actually create some plots. The Readme file is always at the root, and when you push that to GitHub, it would look really nicely. It would be like the first page of the, actually here I haven't rendered it, but you will see a really nice report produced, just like the one you're reading here. That will appear as the first page on GitHub. And then, well, the directory data raw that contains any raw data. From there, you read the data sets, you wrangle them, and then you stick them into the data folder, which I don't have here yet. So let's create it. So in the data folder, there is where I could put any processed data. And where I would process the data, well, I would process it in the wrangle file. So my wrangle file looks like something like this. I need to create first use some packages, for example the package read Excel, and then I would use the here package. We talked about that. I know we're very close to the end. I'm going to create a path with here. The path, if I do quotes and press tab, I already have the opportunity to navigate inside my project. So let's navigate to data raw, and then hit a tab again and autocomplete the path that exists there. So that would be my path. So I can now use that path. So the path looks like this. So I can just read it with the function read Excel, and that will produce the raw data. Here we are, sorry. The raw data. So the raw data looks like this. Let's make this a little bigger. So now say that wrangling the data for me means I don't know, maybe I want to change the names to something more descriptive and call it the names in speed and dist. I want them speed and distance, for example. So now my clean data is now I change the names to that, and that I can call clean data, basically, right? So now I write the clean data, and I'm gonna write it with the readr package with write CSV. So now I'm gonna use the reader package, so I'm gonna put it here. I can remove now the namespace from here, and I'm gonna again create a path with here. It's going to be inside the data directory, and I'm going to call it data.csv. So that will, or should, because I forgot to tell which data set is the one I want to save. So this could be it. Data, save the data here. So now if I go to my, so this could be my Wrangle file. So if I go to Readme, and this is going to be the end of the meetup, if I run this file again, if I need it, by pressing here, the report that I produced with this Readme file now shows that inside the data folder there is a data.csv file, which more closely follows Jenny Bryan's recommendations. Okay, so that's the end of what I wanted to show. Do we have any parting notes, comments, questions? Okay, then thank you again for joining me in this the end of the first part of the series. Next time, again, we're gonna have, I think, a guest, if the guest confirms, and then we're gonna resume with some more technical aspects of what I forgot to teach you about R. Thank you. See you next time.